Okay, so my fourth little video clip here for creating these formulas is ready to go here. So let's watch that. Okay, so now we have three formulas. We have x equals x0 plus velocity times time. This is the final position or displacement with the constant velocity formula. This is similar to the next formula, final velocity with constant acceleration formula. How do I find my final velocity if I know what the constant acceleration is? Then we said, how do I find my final position if I have a constant acceleration and I know my initial and final velocities? Okay, so now what if I don't know my final velocity? Okay, what if I don't know my final velocity? So here's what I'm going to want you to write down underneath this. What if I don't know final velocity? So what I want you to write down is that you do know, okay, you do know a formula that puts final velocity in terms of initial velocity and acceleration in time. Okay, I know this formula, so maybe I could substitute this in for this. Okay, so what we're going to say is we know V equals V0 plus AT, so substitute this in for final velocity or V in the displacement with constant acceleration formula. And think about this as you're writing it out. Substitute this in for final velocity in the displacement with constant acceleration formula. Now, recognize that I'm not ever going to ask you to derive these equations or come up with these equations on your own. I'm putting this in here for the more mathy of you, those of you that really want to know how we got these equations. It would be bad of me to just say, here, these are the equations you need, without me showing you how I got those equations. I need you to see how I got these equations. I don't need you to be able to repeat it back to me. Although, if you're interested, maybe in some extra credit sometime, you could show me that you know how we got these or how we derived these, and I would give you some extra credit for that. Okay, so if you could go through the same process we're going through here without any resources, I would give you some extra credit. Okay, so let's do that then. Let's say we know that x equals x0 plus 1/2 V0 plus V times T. And now I'm going to substitute in I'm going to substitute in this for this. And this is going to give me x equals x0 plus 1 v0 plus v0 plus at times t. Okay, now I can simplify this. I've got two v0s. Okay, so I can say that x equals x0 plus 1/2 times 2 v0 plus at times t. Okay, now for this first term here, 1/2 is going to cancel out the 2. So I'm just going to end up multiplying v0 times time, right? So now I'm going to get x equals x0 plus v0 times time. Then if I multiply the 1/2 times at and multiply that times t, then I'm going to get 1/2 times at squared. Okay, so 1/2 times at times t is going to give me 1/2 at squared. So this is going to be my next formula, and we're going to call this displacement or final position, whichever you prefer. Displacement with constant acceleration. Okay, and you're going, wait a minute, Marshall, we just called the other one displacement with constant acceleration. How are we going to make this one different? So we're going to just say displacement with constant acceleration, no final velocity. Because I don't have a final velocity, right? And so, if I have the acceleration but no final velocity, I can use this formula. And we'll use this formula a lot, okay? Especially because a lot of times x0 is going to equal 0, and v0 times time, v0, my initial velocity, will be 0. So this term drops out. And a different form of this might just be x equals 1/2 plus at squared plus 1, x equals 1/2 at squared. Okay, you may have seen that in your algebra classes. In any case, this is our next formula. So let's go ahead, and we're going to create one last formula after this one.
Okay, so we'll start the video for this last one. It's going to run a little longer than the end of this video, so we'll end up going into a fourth video for this, but that's okay. So go ahead and start watching this one.
Okay, so just like we've done in the last videos, let's start by saying this is what we've got already. I've got a final position. I want to know my final position if I have a constant velocity. So this is my final position with constant velocity formula. I want to do the same thing with velocity. I want to know my final velocity if I have a constant acceleration. Okay, and then we created a formula that said, well, if I've got a constant acceleration and I want to find how far I go, but I don't know what that acceleration is, but I do know what the final velocity is, I can say x equals x0 plus 1/2 times v0 plus v times time. Okay, and so now I've got my final position, or my displacement, if I have both my initial and final velocity. And so we're calling this displacement with constant acceleration. And saying constant acceleration reminds me that I can just substitute my average velocity in there. And then we also just created a formula that tells me that I can find how far I go if I just have my initial velocity and the acceleration with no final velocity. So we called this the displacement with constant acceleration, no final velocity. Okay? So these are my first four. Now, I desperately need a formula that I can use to solve for things if I don't have time. What if I haven't been given an amount of time? You can see all of these other formulas have time in them, but what if I haven't been given time? So hopefully it makes sense that we can do the same thing that we did in the last one. I could find a formula maybe that I can set t equal to the rest of the formula and substitute that in. So here's what I'm going to do. I'm going to start by saying find and this is below the line, here's what I want you to put in your notes. Find a formula that I can solve for time and then substitute that in for t in another formula. Okay, and we'll use the same formula we used for the last one to substitute into. Last time we used x equals x0 plus 1/2 v0 plus v times time. And last time we substituted in for v, right? We didn't have final velocity, so we substituted something else in for that. This time we're going to substitute something in for t. And we're going to use the same formula we used last time, except we're going to isolate t instead of v. And so if we start with v equals v0 plus at, we can solve for t by first subtracting v0 from v, okay, and then dividing by a, and that will give us t equals v minus v0 over a. Okay, now this is going to be a little bit more tricky because we're going to have to substitute this in for t, and the algebra is going to be a little bit more difficult. So let's substitute this in first. So I'm going to say, hey, let's put this in for t here. And if we do that, we get x equals x0 plus 1/2 times v0 plus v times v minus v0 over a. Okay? Now,
so let's stop here because we need to go to another video because this one's running out of time. But this next one will be the last video for this session. Okay. Stop video.